This is how I'd use the simulation in front of a class to explain the relationship between voltage, current and resistance. I'd introduce it by saying something like, we've seen that current is just the flow of charges, which we represent by these black dots, and voltage is something like the amount of energy that each charge carries, which we've represented by the amount of red stuff per black dot. Now let's see what happens when we change the voltage of the battery and the resistance of the bulb. What do you think will happen to the amount of red stuff around each charge if we increase the voltage of the power supply? Well, it should go up. Well, let's increase the voltage of the power supply and see. And what happened to the speed of the charges? Well, they sped up. So what's happened to the current? It's increased. And what happened to how quickly the red energy circle around the bulb is expanding? Well, that increased too. And what would happen to the brightness of the bulb? It would be brighter. And what would happen to how quickly the battery runs down? The battery would run down quicker. There are two reasons the bulb gets brighter. What do you think they are? Charges with energy arrive quicker at the bulb, and each charge loses more energy as it passes through the filament. So, does the brightness increase because only the current increases, or only the voltage increases, or both increase? Well, it's both. The brightness increases because the current through the bulb and the voltage of the charges entering the bulb both increase. Strictly, the brightness depends on the PD across the bulb, but since we haven't introduced PD yet, and since we're talking about this very simple circuit, then the PD is the same as the potential on the positive side of the bulb. Note that the new potentials are set up instantly around the circuit as the battery voltage changes. The battery doesn't just increase the potential of the charges near it and then wait for those charges to reach the bulb. That's why our simulation is not what's known as a donation model, like bread vans carrying loaves of bread. It's a mathematical model with physics hard baked into it that has a visual output. The model accounts for the fact that the charges find out about changes to the circuit, like the power supply voltage changing or a switch opening or closing, almost instantly, even though the charges themselves move very slowly. I could also change the resistance of the bulb. In practice, you can only do this by replacing the bulb each time, but that's the advantage of a simulation. We don't need to do that. We're not going to go into what resistance means just yet, only that if you have more of it, then you get a smaller current for a given battery voltage. As I increase the resistance of the bulb, what happens to these three things? The battery voltage stays the same. The pattern of voltages around the circuit stays the same. The current through the bulb decreases, and how quickly the energy circle expands more slowly. So are high resistance bulbs brighter or dimmer than low resistance ones if you connect them to the same power supply? They're dimmer. Why? Because each charge loses the same amount of energy going through the bulb, but the charges arrive at the bulb slower. There's a smaller current. This is a really important point. Power supplies respond to changes in load by changing the current they deliver and keeping their voltage the same. They are constant voltage providers, not constant current providers. Notice how a high resistance means a dimmer bulb. So the battery is working less hard. Power supplies don't struggle to provide a fixed current, which is why it's really dodgy to say that resistances resist the flow of current. There's no fixed current that the battery is trying to produce. Resistances are not like frictional forces. We respond to frictional forces by trying harder, but batteries don't. They try less hard. They're like a teenager who'd rather stay in bed. If you make getting up harder for them, they respond by trying less hard, not by keeping their level of effort the same.